Welcome to our presentation on nanoparticles and prostate cancer diagnosis and treatment.
My name is Razeen.
My name is Rahul.
I'm Toby.
And I'm Joshua. So the types of nanoparticles used in this study were gold nanoparticles. They're abbreviated to AUMPs. These nanoparticles are synthesized using the citrate reduction method, and in this method, the citrate ions are used to reduce the gold ions in the solution, and it'll produce spherical particles with like an average diameter of 16 to 18 nanometers. And the small size and the uniform shape that they take on makes them ideal for biomedical applications. Because of these characteristics, it allows them to like efficiently circulate throughout the body, and it effectively allows them to penetrate the cancerous tissues. The gold nanoparticles are coated with polyethylene glycol, which makes them more stable inside the body, and it stops the immune system from attacking the nanoparticles. Folic acid is also added to the nanoparticles to target the actual prostate cancer cells, and it can sense and attract, and the cancer cells can sense and attract the folic acid. And finally, they load the actual chemotherapy drug, and it's called docetaxel, and they load that into the nanoparticles. And then down here at image A and B, you can see it's like electron microscope imaging of the actual nanoparticles, so you can see the spherical shape in A, and in B you can see like the relative size, like how small these nanoparticles actually are. And yeah.
So now the question is, how do we apply these? So nanoparticles are being used to treat the prostate cancer, and the nanoparticles are being tested as a new way to treat the cancer. So usually people use like a chemotherapy drug, and the problem with these is that they have a negative side effects. And now this can be through like balding and different various things that you do not want. So in the current form, this drug called docetaxel, also known as DXT, causes a lot of serious side effects, and that causes it to affect both the cancer cells and the healthy cells. So the goal of the article is actually to develop a more effective and safer way of delivering the DXT directly into the cancer cells via the nanoparticles. And this issue is extremely important because prostate cancer is one of the most common cancers in men across the entire world. And by improving the efficiency of the chemotherapy, the prostate cancer can be utilized in a way to reduce pain, nausea, and other very bad side effects while making the treatment more effective. Now, researchers are also care about this because targeted drug delivery can improve the survival rates and makes the cancer treatments more precise so they can target the cancer cells more effectively. And here you have the image of the docetaxel.
All right, so what exactly do the nanoparticles do? The method of prostate cancer treatment designed by the researchers includes many steps or layers, each contributing to the improved effectiveness of the treatment. So first, gold nanoparticles were made as the base or carrier to which each of the following compounds were attached. Two, the surfaces of the gold nanoparticles were coated with polyethylene glycol to keep them stable in the bloodstream, as well as reducing the likelihood of the nanoparticle being attacked by the immune system. Three, folic acid is attached to polyethylene glycol so the nanoparticles could recognize and stick to prostate cancer cells in a process called targeting. And four, docetaxel, also known as the chemotherapy drug, is encapsulated inside the nanoparticles. And when these nanoparticles enter the body, the folic acid helps them find prostate cancer cells and it attaches to them. And then the cells absorb the nanoparticles through a process called endocytosis. And the drug slowly releases inside the cancer cell over a period of up to 72 hours, which kills them very effectively.
Moving on to what exactly the nanoparticles do. As you can see on the image to the right, the image models how the gold nanoparticles are made to deliver the chemotherapy drug docetaxel. At the top of the image, you can see gold nanoparticles, which are created by reacting chloroauric acid with sodium citrate at a high temperature. This reaction forms a small and round particle. These gold nanoparticles are coated with a molecule called polyethylene glycol, which helps keep them stable in the bloodstream and prevents them from clumping together. Next, folic acid is used in polyethylene glycol using a chemical process called EDC, also known as NHS coupling. The folic acid helps the nanoparticles target prostate cancer cells since those cells have special folate receptors. Finally, docetaxel is added to the surface of the nanoparticles so it can be carried directly to the cancer cells. The image on the right shows how researchers built a good nanoparticle system step by step to deliver chemotherapy drugs more effectively and safely.
So how does this improve upon the current technology for this application? Well, using the nanoparticles for this treatment has many benefits when compared to the ordinary chemotherapy treatment. The folic acid on the nanoparticles helps them find and attach to the prostate cancer cells, which makes the treatment more targeted. The nanoparticles release the drug slowly over time instead of all at once. So this allows it to lengthen the drug's period of activity within the body, and the drug is then transported directly to the site of the cancer cells, which reduces the negative impacts on the healthy cells. And then the nanoparticles are also exceedingly efficient when compared to current method, with about 96% of the docetaxel being successfully loaded into the nanoparticle. On top of this, the polyethylene glycol coating keeps the nanoparticles stable and stops them from clumping together or breaking down too quickly. Regular chemotherapy circulates the drug throughout the body rather than locally around the tumor. And this causes harm to healthy cells while wasting some amounts of the medicine. Nanoparticles improve this process by delivering the drug exactly where it's needed. It makes the treatment safer, cheaper, and much more effective.
Here are our references, and thank you for listening to our presentation.